Okay, we're at the top of the hill here on this sequence, and we've dug a pit. And so one of the first things that you want to do when you open up a soil pit like this is looking for soil horizons. What kind of development has happened here in terms of pedogenic processes, and can you see those, identify those on the pit face? And so if you look at this particular soil profile, there's not a whole lot happening here actually. If we look over here, we can see that maybe on the surface here we have this darker layer, and then below that we have this lighter colored material pretty much to the bottom of the pit, which is about 70-80 centimeters deep. And so there's really basically only two horizons here, this surface horizon and then this horizon below it. I should also point out that when we're dealing with forest soils, the other important thing is the forest floor. And in this particular case, because this is really what separates forest soils from ag soils, is this amount of litter that has been deposited on the top. And you can see this litter here, there's old needles from last year are still visible. This is your L layer, so the litter. Underneath that we have a little bit of fragmented material, and so this is litter that has started to decompose. And then below that, we're into our mineral soil. And typically, we call this kind of litter, it's classified as a moor litter type. And it is interesting in that you can actually lift it right off of the mineral soil. So many of our boreal forests here in Saskatchewan have this moor classification type for forest floor. And so it sits here on the mineral surface. And then underneath that, we have this darker layer here. And you can see that it is much darker than below, and we would call this our AH or AHE horizon. And so it probably runs just something like this, and is probably 5-6 centimeters at the most, and even thinner in different places. And then below that we have this lighter layer, and I just want to show you a comparison here between the two. You can see that there's a real distinct difference in the colors here. And this looks like it hasn't been impacted at all by any pedogenic process. I mean, water moving through the soil profile. And so we would actually classify this as a C horizon. So we have an AH, AHE in the top here because we got a little bit of white in here, the salt and pepper effect. And then below that we have our C horizon. And when we actually then classify this out, this actually becomes a regosol. And when we go through the classification scheme, this will end up being a orthic regosol. So these are very, and I guess the next thing we have to talk about is texture. So we need to talk a little bit about texture because that's an important aspect related to water holding capacity. And we have the two horizons here, the AH horizon and then the C horizon. You can see really distinct differences in color. However, when you dry this material out in your hand, it comes out to be a fine or very fine sand. And because of that, we can then, once we have our textures, we're able to figure out our drainage classes for our different landscape positions. And so this book is the field guide for describing soils in Ontario, and a lot of students will buy this book. I think there's a newer version out at the moment. But in there is a chart on drainage classes, and you will find one of these from your instructor. And so we just want to talk about what is the actual drainage classification for this site. And when you go through this key, it asks, are you in an organic soil? And no, we're not an organic soil because we're at the top of a hill. Are there any models present? There aren't any models here. Are there any gray colors, which would indicate saturated conditions? And so no. And then the next asks about the texture types. And so is it very coarse sand? Is it a medium sand? Loamy sand, loamy very coarse sand? And are the particle sizes 35% of the volume of the particles greater than 2 millimeters in size? And if you look at this, you can tell that that's not the case. And so it's just really fine sand. And so the next one down is a fine sand, and you go across and yes, and so the drainage class for this particular site would be rapid. And that kind of makes sense. We don't have a whole lot of vegetation here on the ground. It's a lot of mosses and lichen, We have jack pine, which are very characteristic of sandy soils and drier sites because they have a taproot to try to access moisture. And so the drainage class for this particular site would be rapid, meaning water moves through this profile fairly easily and resulting in the vegetation that we see here. So there's a nice relationship between the soils that we have classified here in terms of this regosol and the vegetation, which is this jack pine. And so this is a very common relationship that you will see in Saskatchewan. Sandy soils, a lot of times you will actually see jack pine growing on that. So what we're going to do now is go down to the bottom of the hill and look at that pit and see if there are any differences in the soil classification in terms of the horizons in that pit, and see what the classification of that particular site is.